Hi class. So today we're going to start independence, and it is the last leg of our probability race. And we're going to start off with what is the definition of independent events. So the definition of independent events is that the probability that one event occurs in no way affects the probability of other events. So question 2 says, how can you test for independence? So the first method that we can use to test for independence is conditional probability. Again, feel free to pause the recording so you can copy down the definitions as I explain it. But conditional probability is given. So if you recall, in our previous lesson, we talked about conditional probability, and this is the symbol for a condition, which this reads given. So if the probability of A given B is equal to the probability of A, then yes, they're independent events. So applying the condition B had no effect on the probability of A. That's one way we can test for independence. The second way is compound probability. And in compound probability, if the probability of A and B is equal to the probability of event A times the probability of event B, again, you can say yes, they are independent. So that is two different ways that we are going to test for independence. Okay, so let's look at question 3. Question 3 says the probability of selecting a purple marble from a bag of marbles is 0.4, and the probability of selecting a big marble from the same bag is 0.55. The probability of selecting a marble that is purple and big is 0.3. Are the events selecting a purple marble and selecting a big marble independent? Okay, so when you're reading that, the key word is and. The fact that they told us in the third probability, they gave us the probability of events A and B, that tells us that we're going to use the second formula, the compound formula. All right, so that formula says that if the probability of A and B is equal to the probability of A times B, then the events are independent. So in this example, the first event is that the marble is purple. So if the probability of a purple marble, and the second event is that the marble is big. Okay, so if the product of those two probabilities is equal to the probability that the marble is purple and big, then we can say that these are independent events. So let's go ahead and reread that and snatch out those probabilities that were given to us. So it says here in that first line that the probability of selecting a purple marble is 0.4. So purple is 0.4. And then it says that the probability of selecting a big marble, here's that 0.4. Let me circle that. And then it says that the probability of selecting a big marble from the same bag is 0.55. The probability of selecting a marble that is purple and big is 0.3. And what we have to determine, I'm going to put a question mark, is this a true statement? So I'm putting a question mark above that equal sign because we need to test that. So feel free at this time, pause the video, multiply 0.4 times 0.55 and tell me what you get. Write that down. Okay, so did you say 0.22? I think that's what I heard you say. And you are correct. 0.3 is not equal to 0.22. Therefore, these two events, the event of selecting a purple marble and the event of selecting a big marble, they are not independent because the probability is not equal. So question 4 says that the probability that it rains on Monday is 0.4. The probability that it rains on Tuesday is 0.2. The probability that it rains on Monday and Tuesday is 0.08. So again, they're providing us the and. All right, so that tells me that we are still using that second formula, which again says that the probability of A and B has to equal the probability of A times the probability of B in order for the two events to be independent. So my first event is that it rains on Monday. So the probability of rain on Monday times the probability of rain on Tuesday. If that equals the probability of rain on Monday and rain on Tuesday, then these two events are independent. So I want you to pause the video and see if you can figure out if these two events are independent. Okay, so did you say yes, they're independent? If you did, you got it right. So when you're reading the sentence, it tells us that the probability that it rains on Monday is 0.4. The probability that it rains on Tuesday is 0.2. And the probability that it rains on Monday and Tuesday is 0.08. In this example, 0.4 times 0.2 does indeed equal 0.08. So yes, because they're equal, they are also independent events. Pause the video and give number 5 a shot. So after you substitute in the corresponding probabilities, this is what you should have. And I just drew an arrow down from 4 to 5 because we're using the exact same formula. So the probability of A and B is 1 over 25. The probability of A is 2/5, and the probability of B is 1/4. So when you multiply fractions, remember we multiply straight across. And if I multiply my numerators, I have 2 over 20. 1 over 25 is not equal to 2 over 20. And 2 over 20 would reduce to 1/10, but regardless, they're not equal. And because they're not equal, they're not independent. Okay, we only have 2 more questions, so let's go ahead and hop to it. Okay, so as we go into 6 and 7, now we're going to practice using the second test for independence, and that's for conditional probability, and that's that the probability of A given B is equal to the probability of A. If the probability of A given B is equal to the probability of just A without that condition, that means that A and B are independent events. So here, there's no multiplying that we need to do. So that makes this formula just a slightly maybe simpler than the first one. So what we're doing is comparing. We have the probability of A, which is 9 over 20, and the probability of B is 1/2. The probability of A given B is 27 over 50. So in order for A and B to be independent events, then the probability of A has to equal that probability of A given B. So in other words, is 9 over 20 equivalent to 27 over 50? And the answer is no. They're not equivalent. Therefore, they're not independent. Number 7 is a little tricky because it says the probability of not A. If you recall, this symbol here, that means not, that little squiggle sign. So if I know the probability of not A, the probability of A will equal 1 minus 0.7. So the probability that A does happen is actually 0.3. So if the probability that A does not happen is 0.7, the probability that A will happen is 1 minus that, which is 0.3. And because the probability of A is indeed equal to the probability of A given B, 0.3 is actually equal to 0.3. The answer is yes. They are independent events. Okay, so just like always, if you have any questions at all, please reach out on Canvas, remind, send an email, request time to conference on Zoom. We're almost at the end, and if you have any questions, communication is key as we finish this last little leg. I hope you're staying safe, and talk to you soon.